Hello guys, welcome back to the part 2 video of electromagnetic induction chapter. Let's get started. Question number 22. So let me read it out. In which of the following devices the eddy current effect is not used? It's a direct question based on the concept of eddy currents. It's in electric heat. Electric heaters are generally works based on the principle of Joule's heating effect. Okay, it is not based on eddy currents. What's the meaning of eddy currents? It's a circulating current in the conductor. Okay, well, check out that. Next 23. Eddy currents are produced when. This is a basic question, comes from eddy current topic. So eddy currents will produces when a metal is kept in a varying magnetic field. When a metal is kept in a varying magnetic field, EMF induces in it, which produces current. Those currents will circulate on the surface of the conductor. Those are called as eddy currents here. Okay, so let's move on to the next topic. That is induction. So 24th question. The magnetic potential energy stored in a certain inductor is 25 millijoules. Okay, so when the current in the inductor is 60 milliampere, the inductor is of inductance. Okay, 24th solution. So it's based on energy stored in inductor. Energy stored in inductor formula 1 by 2 Li square. Energy they have given it is 25 millijoules. Mill is 10 power minus 3, which is equal to 1 by 2. L I have to find out. I value is 60 milliampere. So 60 into 60 into 10 power minus 3 square is 10 power minus 3 into 10 power minus 3. Keep it as it is, because 10 power minus 3, 10 power minus 3 will get cancelled. If this 2 goes left side, it will become 50. 50 is equal to L into 3600 into 10 power minus 3. Then finally it can be replaced as 500 by 36. 500 by 36 is approximately 13.89 henries. So which option? Option D is the correct answer. Got it? Okay, let's move on to the next question. Next question is also of the same type. A current of 2.5 ampere flows through a coil of inductance 500. Magnetic flux they are asking. What's the formula for flux linkages? Flux linkages or magnetic flux, total flux linkages is equal to L into I, which is called as total flux, right? Okay. Okay. Flux linkages is nothing but total flux. It is actually replaced with N into phi. So N represent total number of turns here. Okay. So finally we are finding flux only. So L value they are given it is as 5 and I value 2.5, which is equal to 12.5 Weber. Which option? Option B is the correct answer. Okay, let's move on to the next one. 26th solution. They given current versus time graph and they are asking voltage versus time graph. What's the formula for voltage? V is equal to minus L into di by dt, right? And one more thing, whenever you integrate a straight line, so formula for V is minus L into di by dt. It means I have to differentiate the current. Now if we know this, if I differentiate a straight line, if I differentiate a straight line which is increasing straight line, you are going to get a constant. Simple example, y is equal to mx plus c format. That's what I'm imagining. Let us say I is equal to m into t. It's a straight line graph. If I differentiate I with respect to time, I'm going to get m. This is constant. That's the meaning here. We are going to get a constant. If you want, I can give one more example. For example, y is equal to 3t is there. It's a straight line equation, right? Let's differentiate dy y with respect to time. You are going to get 3. 3 is a constant value, right? So that's what I mean. If you differentiate this straight line varying with respect to whatever the variable they have given, if you can differentiate that, you are going to get a constant. Now one thing I am sure that I am going to get a straight line. If you observe option A and option B, which are not a constant line, so these two options are wrong. Let's check out the remaining two options also. Option C is sinusoidal. I'm not going to get a sinusoidal if I differentiate a straight line. So this is the only possible option which matches. Okay, so similarly 27 also we can answer like that on this 27 solution. The current in the coil is varying with respect to time as shown in the figure. The variation of induced EMF with respect to time we have to find. Induced EMF with respect to time, we have a straight line. So look at this. So if you differentiate this, what you are going to get is formula is induced EMF is minus L into di by dt, right? So if you differentiate a straight line, you are going to get a constant. We have two possibilities, option A and option B. So whatever the option which is following this rule, that's what we have to get the answer. Let's say from 0 to t by 4, slope is positive or negative? Check out that. From 0 to t by 4, slope is nothing but di by dt. So which is positive? If slope is positive, E is going to be negative or positive? Negative. One thing I know that E is going to be a constant value. Okay, so what about from t by 4 to t by 2? T by 4 to t by 2 is the slope is 0. That is it. There is no change in current with respect to time, which is equal to 0. Then induced EMF is equal to 0. Next, from t by 2 to t by 3 t by 4. In this case, the slope is negative. So slope is nothing but rate of change of current with respect to time, which is negative. If slope is negative, induced EMF is going to be positive. Observe which option matches for this. Definitely option A. Check out that. For question number 27, option A is correct. Just check out. So I told clearly option D is not matching even though it is a constant. Because of this reason, based on the slope only we can answer this. Let's solve question number 28. Question number 28 solution. So a long solenoid has 500 turns. When a current of 2 amperes is passed through it, the resulting magnetic flux linked with each turn of the solenoid is 4 into 10 power minus 3 Webers. The self-inductance of the solenoid they are asking. Okay, what's the formula for flux linkages? Flux linkages is replaced as psi, which is equal to n phi, which can be replaced as L into I. What is the question they are asking? They gave number of turns. Number of turns are 500 and flux is also given, which is 4 into 10 power minus 3 Webers. And the current is also given. We have to find out L. Current is 2. 2 2s are, you are going to get 1000. Then L is equal to 1 Henry. Which option matches? Option A is the correct answer for question number 28. Next, question number 29. Let me read it out. Next, question number 29. Two coils of self-inductances 2 millihenries and 8 millihenry are placed so close to each other that effective flux in the coil is completely linked with the other coil. They said it is completely linked with the other coil. This point is important. Next, then the question they are asking is mutual inductance between the coil. By giving self-inductance of two coils, formula for mutual inductance is M is equal to K times of root of L1 into L2, where K is coefficient of coupling. As flux is completely linked with the other coil, K is equal to 1. K is called as coefficient of coupling. How much magnetic flux is linked with the other coil? So it is decided by K value. Then M is equal to L1 is 2 millihenries, 2 into 10 power minus 3. L2 is equal to 8 into 10 power minus 3. So which can be the answer that we are going to get is 4 into 10 power minus 3, that is 4 millihenries. Which option? Option 4 is the correct answer. Got it? Very good. Next, question number 30. So length for a coil having L is equal to, not length, self-inductance L is equal to 2 millihenry. Current flows through it and I is equal to T square e power minus T. Then time at which EMF becomes 0. Okay, first of all, let me find out EMF, that is L into di by dt. So let me differentiate this. This is 2 into 10 power minus 3 into, so just differentiate with respect to time. Current is differentiated with respect to time. Apply U into V formula so that we can answer it. U into V is U V dash plus V U dash. Let me treat T square as U and V is e power minus T as V. So U V dash, that is T square into V dash is minus e power minus T plus V U dash e power minus T into 2T. So this is the differentiation of I with respect to T. I used U into V formula. They said we have to find out time at which EMF is 0. Equate EMF to 0. This value also becomes 0. So finally I am going to left with e power minus T into 2T is equal to T square times of e power minus T. E power minus T will get cancelled. T also will get cancelled. Then T is equal to 2 seconds. This is the time at which EMF is going to be 0 for the given current. Okay, next one. So they gave a sinusoidal function here. Okay, so question number 31 solution. Two coils have mutual inductance M given, which is equal to 0.005 henries. General formula for induced EMF in terms of mutual inductance is M into di by dt. Okay, so let's go ahead. So current changes in the first coil according to the equation I is equal to I naught sin omega t, where I naught is equal to 10 ampere, omega is 100 pi. The question they are asking is the maximum value of EMF in the second coil. Okay, so induced EMF is equal to M into di by dt, which is equal to M value is 0.005. So I they have given it is as I naught sin omega t. So if you differentiate this, we are going to get cos omega t, omega into cos omega t. They are asking maximum value. So this is I naught into omega t into omega into cos. Let me repeat this again. So I naught constant, which will comes outside. Sin omega t differentiation is omega cos omega t. I need maximum value. This is the maximum value of individual. Coefficient of cos or sin function is the maximum value. That's what we have to find out, which is equal to E maximum is equal to 0.005 into I naught is 10, omega is 100 into pi. So finally this 3 and these zeros will get cancelled. Answer is going to be 5 into pi volts. Which option? Option B is the correct answer. Got it? Next, question number 32. Let me finish. See, if N is the number of turns in a coil, the value of self-inductance varies as. Okay, so we know the formula for self-inductance. So direct formula, mu naught N square A by L. This is the formula for self-inductance of a coil. In terms of number of turns and length, it is directly proportional to N square. So which option? Option C is the correct answer. Next, question number 33. Let's solve that. So what is the self-inductance of a coil which produces 5 volts when current changes from 3 ampere to 2 amperes in 1 milliseconds? Okay, so what is the self-inductance? Then E is equal to L into di by dt. So current is changing from 3 ampere to 2 amperes in 1 millisecond. That means L into I2 minus I1 by T. So initial time is 0. V value they are given, that is V. 5 volt. So L into I2 is, it is changing, I need magnitude only. So 3 ampere to 2 ampere we are finding. So the difference is going to be 1 ampere, right? Difference is 1 ampere divided by time is 1 millisecond. So 1 milliseconds. So final answer is L is equal to 5 millihenry. Which option? Option B is the correct answer for question number 33. Got it? Let's try question number 34. If number of turns per unit length of a coil of a solenoid is doubled, number of turns per unit length, that is N, then what happens to self-inductance of the solenoid will be? Okay, so if it is doubled, then what happens to self-inductance? That's what we are asking. Okay, let's, L is equal to mu naught n square A by L, right? Let me replace small n is equal to n by L, and capital N is equal to n into L, right? Let me replace it here. Then n is equal to mu naught n square L into A, because denominator L will get cancelled out. Then L is directly proportional to n square, right? So L2 by L1 is equal to N2 by N1 whole square. N2 is how many times? Doubled, that is 2 times of N1 divided by N1. N1 will get cancelled out. Then L2 is equal to 4 times of L1. Which option? So it becomes 4 times. For 34 the question, option D is correct. Okay, next question number 35. For question number 35, a 100 millihenry coil carries a current 1 ampere. Energy stored in it. Energy stored in a coil formula 1 by 2 L I square formula. So 1 by 2 into L is 100 milli. 100 into 10 power minus 3 carries a current of 1 ampere, which is equal to 10 power minus 1. 10 power minus 1 into 0.5. It's going to be 0.05 joules. Option C is correct for question number 35. Next, let's try question number 36. Question number 36 answer. The current in self-inductance L, L is equal to 40 millihenry is to be increased uniformly from 1 ampere to 11 ampere. Let's say I1 is equal to 1 ampere and I2 is equal to 11 ampere. Then what about change in current? Change in current is equal to 10 ampere. Okay. In how many seconds? Time is also given, which is 4 milliseconds. The question they are asking is induced EMF. Induced EMF is equal to L into di by dt. Change in current is 10 ampere. L is 40 into 10 power minus 3. Change in current is 10 amperes. It is 10. Correct only. So it is 10 ampere divided by time is 4 milliseconds. 4 into 10 power minus 3. 10 power minus 3 will get cancelled, and it's going to be 100. Which option? Option A is correct for question number 36. Got it? Next, for question number 37. 37 is a theory question directly. An inductor may store energy in the form of magnetic field. Option C is correct. Inductor stores energy in the form of magnetic field, where capacitor stores energy in the form of electric field. Got it? Let's try question number 38. 37 completed, right? In question number 38, a wire loop is rotated in magnetic field. The frequency of change of direction of induced EMF. So generally formula of so if a wire of loop is rotating in a magnetic field, induced EMF is going to be of sinusoidal like this. When you get a sinusoidal, in one complete revolution, it covers one half cycle and one positive half cycle and another negative half cycle, right? This is one complete revolution. In one revolution, so its direction changes twice. Which option matches? Option D is correct. Got it? Okay. Question number 39. Let me solve that. Okay. So in a region of magnetic field, B is equal to 10 power minus 2 Tesla. A circular coil of radius of that coil is 30 centimeter into 10 power minus 2 meter. Of resistance R is equal to pi square ohms is rotated about an axis which is perpendicular to direction of magnetic field, forms a diameter of the coil. If the coil rotates at 200 rpm, the amplitude of alternating current induced in the coil. Okay. The formula for induced EMF is equal to B A N omega. This is the maximum value of induced EMF. They are asking current, right? So maximum value of current, magnitude of current is, just replace it with BA omega into N. N is number of turns divided by resistance. Resistance is R. This is the formula for magnitude of maximum induced EMF. So they've given everything. You just have to substitute only. B is 10 power minus 2. Area is pi r square. Pi into R value is 30 into 30 into 10 power minus 4 divided by into N value. N number of turns. Did they give number of turns? Check out. No, it's just a one coil. Okay, but they're given omega. So omega, they're given it in terms of rpm. We have to convert that into radian per second. First of all, let me convert that, then we'll answer. So omega, they're given in terms of radian per second, that is 200 rpm. It can be converted into radian per second. So rpm is nothing but revolution per minute. One revolution is 2 pi radians minute. 1 minute is 60 seconds. So this is the way to convert rpm into radian per second. It's going to be 20 pi by 3 radian per second. Okay, so this is the value of omega. Now let me substitute I maximum, I mean, right? I maximum is equal to B value 10 power minus 2. A is pi r square. R is 30 into 30 into r square is 10 power minus 4 into omega is 20 pi by 3 into number of turns is 1 divided by resistance of the circuit is pi square. Pi square will get cancelled. 3 tens are 10 power minus 2 into 10 power minus 4 is 10 power minus 2 into 10 is 10 power minus 1. So then I maximum is equal to, here we have 20 into 10, 200. So 10 power minus 2, this will get cancelled. You are going to get, so if we calculate all these things, the answer is going to be, so this 10 power minus 2, and here we have 10 power 2, that will get cancelled out. Here I have 30 into 2. 30 into 2 is 60. 60 into 10 power minus 4, which is 6 into 10 power minus 3, which can be replaced as 6 milliampere. That's the answer. Which option matches? Option C is the correct answer. Okay, so let's move on to the next one. Let's see the next question. Two conducting circular loops of radius R1 and R2 placed in the same plane with their centers coinciding if R1 greater than R2. Okay. Question number 40. There are two loops, circular loops of different radius. And one more thing they said, R1 is greater than R2. Let's imagine this is R1 and this is R2. So because of this loop 1, loop 2, A magnetic field will produces in loop 2 that will interlink with the loop 2. Let's find out that. What is area of coil 2? Area of coil 2 is equal to pi r2 square. First of all, tell me what is the magnetic field induced by coil 1? B1 is equal to, at the center, mu naught I by, let's say current is flowing through the coil 1. Okay. So if current is flowing through coil 1, then formula for magnetic field at the center is mu naught I by 2 pi r1. Okay, so the question they're asking is mutual inductance M between them is directly proportional to. That's what they're asking. So what's the formula for flux linkages? Flux linkages, as we have only one loop here, flux linkages phi is equal to M into I. Instead of L into I, we are writing M into I because so it is a mutual inductance. So flux is equal to B into B1 into area. B1 is magnetic field produced by coil 1. A is area of coil 2. So M into I. So from this B1 is mu naught I divided by 2 pi R1 into area pi R2 square, which is equal to M into I. I will get cancelled. So finally M is directly proportional to R2 square divided by R1. So which option? Option D is the correct answer. Got it? Current is flowing through the coil 1 and magnetic field is produced. Current is flowing through the coil 1, so magnetic field produced on coil 2. This is the procedure. Okay, so let's try the another question, 41. A big circular coil of 1000 turns and average radius 10 meter is rotating about horizontal diameter 2 radian per at 2 radian per second. So number of turns they have given, it is 1000. Average radius is equal to 10 meter. Omega is equal to 2 radian per second. If the vertical component of Earth's magnetic field at that place is 2 into 10 power minus 5, B is equal to 2 into 10 power minus 5 Tesla. Electrical resistance of the coil they are given. So R is equal to 12.56 ohms. This can be replaced as 3.14 into 4 times. If you multiply 3.14 by 4 times, you are going to get this value, which can be replaced as 4 times of pi. Resistance 12.56 is nothing but 4 times of pi. The question they are asking is maximum induced current. So earlier we solved this. Formula for maximum induced current is E maximum by resistance for maximum current. E maximum is NAB omega divided by R. N value 10 power 3, A value radius they are given, it is going to be pi r square, R value is 10 square, B value is 2 into 10 power minus 5, omega is 2 divided by R value is 4 into pi, pi will get cancelled, 2, 4 will get cancelled, 10 power 3 into 10 power 2 is 10 power 5, I maximum is equal to 1 ampere. Which option? Option C is the correct answer. Got it? Okay, so let's try another question. Question number 42. Let me read it out. A 12 volt 60 watt lamp is connected to the secondary of step down transformer whose primary is connected to AC mains 220 volts. Let me draw the circuit. This is the circuit. This is primary and this is secondary. Secondary bulb is connected 12 volt and 60 watt. For primary supply voltage is given, that is 220 volts. They said it is a step down transformer. That means voltage increases or decreases. Voltage decreases. Assuming transformer is ideal, what is the current in the primary winding? That's what they are asking. We know that input power is equal to output power. Let's use that method. So they have already given output power, which is equal to 60 watt, and input power is I1 into V1. I1 into V1 value is already given, which is equal to 220 60. Then I1 is equal to 60 divided by 220. which can be replaced as 3 by 11, which is approximately equal to 0.27 ampere. This is the answer. Let's try. So which option matches here? 0.27. Option 4 is the correct answer. Okay. Next, last question of this chapter, question number 43. Magnetic energy stored in an inductor of inductance 4 microhenry carries a current. Formula for magnetic energy is 1 by 2 L I square. So that's what we have to find out. 1 by 2 L is 4 into 10 power minus 6. Current is 2 square I square. 2 square is 4. So which can be replaced as 8 microjoules. Which option matches? Option D is the correct answer. So this is what complete chapter is all about. Hope you understood and utilize this opportunity well, and try to go through the solutions again and again so that it will be clear for you. Until you understand, go through it, and all the very best. Thank you for listening it. Thank you for your patience. Have a nice day. Bye.